All right, good morning. Morning, everybody. If I could have your attention. Calgary, let me know when you have me. Can somebody also watch to let me know, like, if Calgary says a thing? Because they're, like, kind of over there. And I have them here, but this phone's going to, like, go to sleep from time to time. So somebody could just, like, keep an eye on the Slack channel. That'd be super. Oh, you're right. I am not there. I'm a ghost. All right, hold on. I have to. Come on, you. All right. Okay. I may, sorry, I had to turn off the camera, to then turn it back on, I think. Okay, that's going to be there in a second. Okay. And let me adjust that so that it actually, all right. Okay. I think that's, yeah, that's live. Although now it's a bit short. All right, I don't know why it would be. Okay. Cool. All right. Good morning. Good morning, everybody. Now that we're finally settled. Yeah. Yeah, now that we're finally all settled and paying attention and about to receive some punitive eye contact. Yeah, hi. Okay, so I was thinking of doing the kindergarten trick of, like, clap once if you can hear me, clap twice if you can hear me. But that only works so many times on adults before they just feel condescended to. So, how was React Week? Yeah. So, how'd you guys feel about kind of like just dealing with the framework, having to think in terms of a framework? How was that for you? Yeah? How was it, like, to be able to make something, you sort of had to, like, think in this other, like, frameworks, like, pattern, right? You kind of got used to that. Also, how was it dealing with, like, you could write really ES6 sort of stuff, right? Like, who experimented, who found themselves writing some more ES6, getting more comfortable with it, right? Was there any language feature in particular that you that somebody can say, like, oh yeah, this thing? What? Deconstructing? Yeah, yeah, I like that. Oh, I love that, deconstructing. Right, argument deconstruction, right in the params your function declaration. Yeah, yeah, so you can just put that. You don't have to be like props and then const equals props. You can put the right at the top where the props would be. If you don't actually need the props object by itself. Yeah, yeah. Switches? Sure. Yeah, yeah. Cool, cool, cool. Well, it's just, yeah, but he's probably like a language feature they hadn't used before and got used to using. So yeah, yeah. Cool. Okay, so this week, you're going to be learning a new language and a new framework. We're going to be learning the Ruby language and the Rails web framework. It is just like React is a framework for front-end stuff, Rails is going to be a framework for back-end. Basically doing what Node and Express were doing, but in a very convoluted way. There will be times where you're going to think that, like, wow, this is really complicated, and I don't know where things are supposed to go. And there's going to be times where you're going to be so mad about Express and be like, I can create so much with just a few command line things. I can make so much stuff, and it does so many things for me. So get ready for that kind of mixed experience. it's just going to be, you're just going to be seeing a lot of magic. And sometimes sometimes Rails does magic for you, and sometimes Rails does magic to you. So why Rails? Well, this is something we're going to get into, is that basically one of the things about the boot camp is we want you to do everything two ways. And what Rails is going to be is a more, is that there's a lot of web frameworks that just have a lot more mechanisms to help you create things, and they decide, oh, different things will have to be in different places. Morning, Conwell. They'll have to be in different places. How you feeling? Good. Good. How was your Thanksgiving? Did you do anything? That's fine. Fine if you didn't. Well, I'm thankful you're here. Yeah. So it's just, there's kind of more mechanisms to do things. And I will say that a lot of frameworks, they either go between being minimalist or, I guess, maximalist. Just, and Rails is definitely like, oh, we have all the things you need probably just kind of built in. Whereas Express is like, we are a bare bones framework on which you can add the features that you want. So it's just a different approach to doing things, and you'll get used to it and see like, okay, I can see why it would be useful for this or that. For me, I worked with MVC frameworks. It's model view controller frameworks like Rails for a really long time, and when I saw the simplicity of Express, it was just like, oh, I finally have control over what's happening. I finally know what's actually going on without it doing stuff for me. So these frameworks that have a lot of features, they're especially great at like doing, they have 20% of the tools do 80% of the work, right? They have like the things that'll help you like make a bunch of stuff quickly, as long as it falls within the sort of thing that they are ready to help you make. Once you want to go out of that, it gets a lot harder. Whereas with Express, everything is equally difficult. So yeah, so, but just like I gave you the framework talk, and just as we kind of got to, you probably got to see a few more language features, we're going to talk a bit about learning a new language. I kind of want to open with the subject of learning a new language, not really open with the subject of Ruby, because, yeah, this is, what is likely going to happen is that we are going to teach you a stack. We're going to teach you a couple of stacks that you could use, right? So if you wanted to, by the way, get to your final project and use exactly the same tech stack you used for your midterm, that would be fine. Like if you can make something impressive with that stack, yeah, fill your boots. That's fine. But we want to kind of also, the point of coming here isn't to learn a specific stack. We try to use stuff that's either really commonly used, or looks a lot like frameworks that are really commonly used, if that makes sense. Like React has a really big market share right now, but it's also kind of sharing that with, like, it's really popular in North America, but in, I think especially like dev shops all over Asia and India. I know India's part of Asia, but like, I think we all know what I'm saying. Was that technically right? That's fine. All right, so there's actually a lot more shops using like Vue and Angular. So different things catch on in different places. You may find yourself working with different groups that have different whatever. So, so we are really looking to less give you a stack that you can build everything in, just kind of teach you how to build things, and then when if you find yourself in front of a different stack, be able to kind of adapt, right? That's our big goal. And the big goal this week, therefore, it is to learn Ruby on Rails, but it's also to learn doing what you've done before in a new stack, understanding, and also now a new language, understanding kind of how to switch between languages, understanding what happens. Because the truth is that we can teach you Ruby on Rails and React and Express and jQuery and Bootstrap, and you're going to be, you may get a job and you're going to be sat down in front of, Django and Vue and Bulma. And you now have to take what you have learned from these other frameworks and apply them. We are teaching you really how to learn stacks more than we're teaching you the stacks themselves. So right now I am doing a contract, and it's in React for the front end, but Django for the back end. So I had to spend a lot of time learning about, okay, how does Django apply things? I'm using a framework on top of a framework, so there's a Django REST framework. So now I'm adjusting my stuff to that. So I have to learn a little bit about how Django does things, but also how this other framework on top that does things. And so it's like, this is still part. I didn't learn all the stacks, right? And you're not going to learn all the stacks. They're going to keep on making them, and especially in the web development world, they keep on making new tools. So this week is about learning to learn more than it is about learning. Right. All right. Learning to learn stacks rather than learning stacks. Okay, so yeah, you are hired. You guys, in this scenario, imaginary scenario, you just got hired. You can tell your friends and family, I have a job now. You're able to move out. I don't have a job for you. I can't hire any of you. I'm not saying I wouldn't if I could. I'm just saying I'm not going to. At least not today. Let's see how the future pans out. Still be nice to me. The snacks, you can keep them coming. So yeah. So you are sat down in front of a computer and you're told, okay, our stack is in Ruby on Rails. And you think to yourself, but I only know Express. What do I do? So I'm going to talk today about, well, this is how you approach learning a new language. I have seen our grads, and their first jobs are in languages like Java or Python or Clojure, which is a Lisp-like language built in the Java framework. And they'll be doing things in, I think I've seen like Perl. I've just seen some wacky languages. Some people have to do stuff in different things. So so this is part of our thing, and I want to talk about how to think about programming languages, how to kind of think about them, how to identify pieces of information about them that's like, okay, that makes sense. So we're going to talk first about, so I'm going to kind of lay out a bit of an analysis framework, and then we're going to think about JavaScript in terms of that, and then we're going to think about Ruby in terms of that. That makes sense. That's how we're going to start out. So let's talk for a moment about paradigms. What are some programming paradigms? Or actually, starts with this. What's a programming paradigm? Has everyone heard this term paradigm yet? Can anyone name one programming paradigm? Object-oriented. That's the one. When I said one programming paradigm, Benji. So yeah, there's lots. So there is. You're absolutely right, Benji. You're very clever. So yeah, a paradigm is just basically like, you might think of it as, this is not a great definition. This is not a technically correct definition, but it's a very useful definition. So this is the one I kind of go with. Is that a paradigm is is almost like a narrative for organizing code. When we organize our code, we organize it into, we think of it as right? So a really common one is procedural. So there's the procedural paradigm. And procedural paradigm is like the stuff we kind of talked about on week 2. Was it week 2 day or week 1 day 2 about JavaScript? I'm not sure if I had you guys for that, or maybe it was the week 1 day 2 breakout where it was like we followed. Did we do FizzBuzz? Does anyone remember FizzBuzz? Okay, where we just like kind of saw where the cursor would go. So procedural is basically, it's a linear set of instructions. And even the functions that we make, like some of them are about getting information, but a lot of them are about just like taking this one set of operations and kind of bundling them up. Do this thing, right? It's kind of like how, what's that one song with all the dances? No, the one with all the dances. It's like a stank. No, a stank. Nope, not the Dougie. Nope, not Cha-Cha Slide. Come on, it was like recent. This is gonna kill me. I know that one of them was the stanky leg. Nope. Yeah. And there was like a bunch of dances, right? So like there's like one big dance that's made of like you do like this sort of small bunch of things, right? I was at a wedding and like there's this 10-year-old who knew all of them, and we were just kind of following the 10-year-old. But it's a linear set of instructions, so each of these is still like, okay, there's a certain set of instructions you do, right? I hope someone makes one of those where you have to kind of do the Fortnite dances. That'd be great. All right. So there's procedural. So it's like, it's basically, we're kind of following our cursor down, and we sort of do things, blah, 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 right? And then there is object-oriented programming. And in that, what's our sort of organizing principle? Classes, right? Everything is a thing. So we have things and definitions of things. That's kind of it, right? We have ways to define how we will make many things. That's what a class is. It's a type definition. And we use that and we make a bunch of things, and it's just like a blueprint, and then we make instances. And then we might take that blueprint and be like, yeah, this is a that, but we're also adding a this, right? It's like that same house, but with an addition or something. I don't know. It's that same house with like a panic room. Another common paradigm that you're going to hear about is functional programming. And with this, you basically isolate out all randomness and side effects and declare your logic as pure functions. Okay, so it's like you should be able to sort of define as much of your logic as possible as pure functions. And what I find with functional programming is that you start with it being like, well, that's ridiculous, and then you just find more ways to sort of like describe more of your logic in the way that's very pure and predictable. So it's like, so basically at any point with a lot of these functions, we could replace the expression like do this, you know, with like the expressions you put in, we could totally replace that with just the result, and our function worked fine. Whereas you can't replace, you know, console log. You can't replace the call to console log with the word undefined. Like that's what console log returns, right? It's undefined. So you can't return the word console log with undefined and expect it to work. Right? Nothing's going to get logged. Yeah? So that is an impure function. And so we, in functional programming, we find ways to kind of push those side effects further and further to the edges, and then have in the middle where it's like, okay, I'm going to kind of pipe this impurity in and fashion it somehow, but I still have a really predictable way of dealing with things like user clicks or file I/O, or you know, I may have an impure function that shuffles a deck, but my, you know, how I deal that out as cards, like I'm doing solitaire, right? Shuffles a deck of cards, but how I actually make the solitaire game is pretty predictable. And when someone makes a move, I know how, given a particular setup, I know whether or not that move is legal or not, right? That part's predictable. That part is very regular. So that's functional programming. It's really affected JavaScript. And there's more paradigms, but these are kind of your big three. Now, I'm going to definitely say that there is sort of an object-oriented versus functional argument, or versus procedural argument. And I have to say that basically the truth is that functional programming and object-oriented programming are just abstractions on top of procedural. In a sense, procedural is sort of more pure and functional. That's not entirely true, but in almost any given practical context, that's the case. It's not true, but that's helpful. Because technically speaking, functional programming has existed on its own before sort of procedural programming, and it's a thing. Anyway, Not the point. So let's take a look at JavaScript. Let's close all of this stuff. Cool. JavaScript. Okay. JavaScript is a high-level interpreted programming language. It is a language that is also characterized as dynamic, weakly typed, prototype-based, and multi-paradigm. So this is the part I want to focus on. We'll get to some of those other words. Programming paradigm. It is multi-paradigmatic. It can be object-oriented, it can be imperative, can be functional, can be event-driven. So the way I'd like to think about it is that, so JavaScript is, it's really just procedural programming with a few OO features and a few functional programming features. Like, it has enough features to do most of these paradigms. So if you're in JavaScript and you want to do things really OO, yeah, totally, you can mostly do that. So one of the features that it has is first-class functions. The ability to generate functions at runtime, return functions. So in functional programming, it's quite often where you'll make some functions that return other functions. And that's a thing that JavaScript had that, especially at the time it was created, not a lot of other languages had. The ability to kind of have higher order functions is something that's used quite a lot in functional programming. I mean, technically if you have that, you have functional programming. So the ability to create a function on the fly, return a function from a function, pass a function to a function, and assign a function as part of a data structure. So, a function can be assigned to a variable. A function can be, it could be a member of an array. It can be the value in a key-value pair in an object. So that's a functional programming thing. And then the array prototype, or the array thing has a lot of the functions that we find in functional programming. So map, filter, reduce. These are really frequently used in functional programming, and it's getting more. It's getting flat map soon. Thank the Almighty. Promises are promises and arrays. I'm gonna get like a little too far, and then I'm gonna reel it right back in. Promises and arrays are examples of a function, a paradigm used quite frequently in functional programming, which is a monad, which is a data structure that has some sort of data as its context, but like does something weird. So in promises, it's all about time. In arrays, it's all about space. But and then there's like a lot of stuff to use them in a very functional way. So between the promises, kind of the way that arrays are built, and then function itself, for that is FP. That is like a lot of what you need to do, a lot of functional programming, and then iterators and generators, so we can finally have there's a few more like advanced features that are still. ES6 even pushed it further towards that. Yeah. Okay, that is a good question. I'm gonna say what it is, and then we're gonna move on, because otherwise everyone's gonna go right to sleep. So, tail call optimization. They have been kind of talking about it, but not a lot of the engines actually have implemented it yet. So tail call optimization lets you do a certain type of recursive thing without ever having a Stack Overflow. Okay. And then for OO features, it has the prototypal inheritance, and now we have classes, which are just syntactic sugar over prototypal inheritance. But with that, you can do a lot of the things that you want to do with OO. And it technically has this, even though this is a broken mess of a language feature. Even though this is a nightmare, it has this. Yeah, so that's, and now it has like statics as well. So their class syntax is just sugar over what we already had, but it kind of makes it a lot easier to do things. Yes. Yeah, well, prototypes are a particular way to make object-oriented programming happen. Prototypes are a specific way to sort of build the taxonomies of like an animal is a bird is a bird, but also a bird is an animal, and it's a way to have the pillars of OOP. So, yeah. All right. Stop asking interesting questions. Your question made me smile. You know, it was a bad question. Just use that. All right. So, I do love this stuff, and just in case anyone was wondering, JavaScript. Let's kind of take focuses off for a second. Although it is event-driven, that's the thing. So it's running context. How does JavaScript get executed? It is slightly compiled. But can I just take a JavaScript, turn it into a binary that my computer can just run? No. Yeah, so it's kind of tied to runtimes. For instance, Node or a browser, right? There's other runtimes for JavaScript, but it's tied to that, and it has just-in-time compiling, which means that it's kind of compiled like, okay, cool, I'm compiling it into something that I can actually do. So, but it has been interpreted in the past as well. Interpreted and compiled. With compiled, it's like I take all the code and I make it into a binary for a specific like setting. Whereas interpreted is like I'm taking a look at your code. I'm a runtime. I'm running. I'm taking a look at the code. I'm trying to figure out what I'm going to do based on it, and then I'm sort of just going. This is the difference between like who's read the Odyssey or the Iliad? Were any of you educated? No. Dante's Inferno? Beowulf? All right. So, fine, yeah. So, okay. Beowulf. That's how it starts, right? You read that part? Okay. And also probably nothing of what I said made sense, right? Because you read an English translation, right? So English translation is somebody who knows English and Old English, different English, sat down and turned different English into an English that you recognize, right? And they thought about like, the first word in Beowulf is what. What. And it's like, what do you do with that? What do you do? So somebody decided, like, should that become like an O or a so, or like someone made that decision about like how to create the best English out of this Old English. Yeah? So that is a translation. And then you just read. You don't have to have that person sitting next to you going through it. You can just be like, oh, this, right? As opposed to an interpreter, which is like me trying to watch a telenovela and having Sebastian be like, oh, she's mad because, you're like, oh, she just said it's not his baby. Right? So that's interpretation, where like the person is kind of like there interpreting for me, right? The same process happens where code with run, like I can take like C and C++ code, compile it down to become an executable that then runs on my machine, and I will probably have to have a few different compilers the same way that somebody has had to translate the Iliad into English and into French and into Spanish and into other languages, right? So so there are different translators that make different versions for different people. The same way, there may be one compiler that takes a program and makes like a Mac version and a Windows version, and a version for this like particular microprocessor architecture and that sort of thing. All right. So with this, we have a runtime that's going to run our code in JavaScript. Okay. The community. What's the JavaScript community like? What do I mean by the JavaScript community? Yeah, so I mean programmers. So I mean communities is a combination of who is using code like yours, who is creating libraries, and also who is talking about code like yours and creating tutorials, podcasts, conferences, yeah, blogs, that sort of thing, right? So yeah, so like who's out there doing that? Because it actually matters, right? When I did a game programming for my bachelor, and I had been doing web development like professionally before that, and my estimations of how long it would take me to do anything had been based on my experience as a web developer. And the one big difference was that web developers are chatty. They at least like know someone that has the term communications in their title somewhere, right? Like they run into them in the kitchen for coffee, right? Like whereas game developers, that is a different world. So there's not as many, like the coding is more complex, and there's not as many people who are like writing about it. And a lot of things they write about it assume that you have like a lot of math and a lot of like, oh yeah, just use the blend-flong lighting model. What's that? Well, it's obviously you have the specular, diffuse, and ambient light. You do this particular based on where the light's coming from and which angle the surface is pointing at. You'll have a different amount of like. You can kind of see how my day was going. So it was really hard. And then I did audio programming. Oh man, that was awful. It remains awful, and I'm still trying to do it. Like it was and is and shall be an absolute bear cat, because there's not really a community to write about it, or the people who are writing about it are assuming that you are like an engineering major or an electrical engineering major, and so like everything they show is like, well, obviously this, and there's like a double integral mathematical formula, and I'm like, let's pretend for a moment that I understood that. How would I actually implement that in code? Newton's method, obviously. So this was a real struggle for me. I didn't realize what the web community was like until I saw a different one. So so JavaScript community is chatty, prolific. They create a lot of stuff. They create so much stuff. There's this thing they call JavaScript fatigue. Like it creates so much stuff that you're not sure what you should be using or doing, right? So it's prolific and really kind of like open to talking about the craft at a low level, right? I wish somebody was able to explain, had been able to explain to me the workings of the fast Fourier transform the way that, like, I've seen a lot of blogs explain promises. If you read a blog post about promises and you don't understand it, just find a different blog post. You're going to keep on reading them until you either you find one that explains it like exactly perfectly, or you've just realized like, oh, they've said the dot then or transform or synchronous or something over and over and over again. I guess that's kind of like the thing, right? That's kind of what it's about. So, yeah. So that's how these are a few ways to tie the language. Another thing I should say that's also coding is typing. How does their typing system work? And in JavaScript is what we call dynamic typing, which is to say dynamic typing, aka weak typing, which is to say that if you have a variable, you can assign a value of any type to that variable. Values have type. A value is a string or a number, or as I don't know if any of you like looked at the console logs when you're doing your library playlist thing, but you would have seen that an object was like library something something, playlist something something something, right? So that is a thing of type library or a thing of type playlist, right? So values have types, but variables don't. Variables have no type restriction. When you create a variable, you can assign a number to it, and then assign a string to it, and then assign an object to it, and then assign an array to it, and there's no way to restrict that behavior. All right? So, okay. So let's talk about Ruby for a second. Ruby. That wasn't what I meant, and you know it. There we go. So Ruby, also multi-paradigm? Okay, yeah, technically. But it really is object-oriented first. And you'll notice that the word prototype isn't here, so it's class-based object-oriented. We can do kind of imperative stuff. We can do some functional programming if we want, but it is really, it is object-oriented first. So Ruby is OO first. Whereas like JavaScript is multi-paradigm, but really procedural first. So this is OO first. With features for imperative / procedural and FP. Okay. Ruby. Where can we run Ruby? Where can we run Ruby? There we are. You say it. It's tough. Where can we run Ruby? So where can we run Ruby? A REPL. So we have to run Ruby on the Ruby runtime. So we have to download a Ruby. If you want to just okay, I have a new computer, I want to get Ruby to work on it. If it doesn't have the Ruby runtime, you have to download the Ruby runtime first. And you have to download like certain versions of the Ruby runtime, right? You're going to find like, oh, maybe this doesn't work on this version, maybe this doesn't work on this version. And you either update your version or you like downgrade your libraries, that sort of thing. So yeah. So it runs in the Ruby runtime. So that's this other program that you actually have to install first to run this. Yeah. So the Ruby community. So Ruby itself is a language that was sort of designed for like first-time users. So there's a lot of kind of like Ruby community has a lot of language hobbyists. I mean, it's true of JavaScript as well, but yeah, I've seen a lot of like really cool projects that are like intended to get people into programming that are written in Ruby, and the same is true of JavaScript, I guess. But I will give you an example. So here is here's a music program that's supposed to be. The idea is that you can live code music, and here's a quick thing that I ran in it. Is this any different? I think I've been watching a lot of Stranger Things when I started writing this. Yeah, I think I was just kind of writing to see like, okay, so what this does is I have a series of notes here, and it goes through them and it plays like each of them, and it like waits a moment to do that. So like if I said wait 0.15 here. I'm sure that sounds like trash over the recording. I'm sorry, Calgary. Uh, yeah, so that's an example of like a thing I've seen kind of Ruby has. So Ruby has a lot of language hobbyists, um, has a lot of Rails users. So so Rails is a good like first language, and then it has a lot of Rails devs as well. So a lot of people who use the Ruby on Rails was like, it especially had this like huge high point in like 2014. The joke was that basically in 2014 a Rails developer um, could just take a piece of paper, write a number on it, and then walk around town until someone paid him that number. Um, and now Rails is kind of like it's still big. It's still used primarily by startups, people who like just want to get up and running. So a lot of Rails devs. So kind of like web use cases as well. It's pretty prolific. It's not as prolific as there's a Ruby Gems. It doesn't have as many libraries, but there's probably a library for whatever you want to do. So probably a library for whatever you want to do. Whereas JavaScript, there's like 7 libraries for everything you want to do. And there's many more libraries for things that aren't even things, right? So, and again, they're pretty welcoming in culture and tone, I've found. And yeah, I feel like I've also seen kind of like the Ruby community is a good community for like finding out about other types of programming. Like you'll see a lot of other types of programming, like I see on YouTube talks that are like written in Ruby, like a bunch of stuff on testing, that sort of thing. Cool. So, right, I'm gonna just dive in and do a little Ruby style syntax example. So let's go to Python tutor. It's gonna go to JavaScript. I'm just gonna do a simple, like, what am I trying to? It's a simple program. Should we do? I guess we could do FizzBuzz again. Yeah, I want to do FizzBuzz. No. All right. So, yeah. So, function FizzBuzz, and let's just basically put in a number, right? And we can say, hey, if num mod 3 is 0, else guess I don't really need the else here, right? Because this is a very procedural language, right? So I'm going to say here, if num mod 5 is 0, return buzz. Oh, and also that, semicolons, right? So FizzBuzz, console.log FizzBuzz4 should be FizzBuzz is not defined. There's a Ruby convention that also helps with that particular problem, but we'll get to that in a second. Okay, 4. That makes about sense. All right, so let's okay. So let's take this code And open up the Ruby one. That's right, there's a Ruby one. Okay, so what am I going to do differently here? Well, for one thing, I'm not going to use the function. There's a few like keyword differences, but you know, who cares, right? Def. And def is short for define. So we are defining the fizzbuzz function. The convention, generally speaking, in Ruby is that instead of using camel case, we'll be using snake case. So everything will be lowercase, and we'll be separating it out. This was the convention I was talking about. All right. So, and then, of course, console log won't be it. It will be put s, put string. Well, there is p, but that actually does a different thing than puts. It's like a fancier version. Well, fancier is anyway. Hold on. Okay. Right. So then we're going to take out our curly braces, and we're going to use end. Okay. So we can go buzz 4. It's going to go through and give us 4. Well, isn't that nice? Another big thing we can do is we can start actually taking out a few of these parentheses if we'd like. I find they kind of cluttered up, so let's go if num that. If we wanted to, we could even make, we don't even need parentheses for the function call. Okay. No more need. Yeah. It assumes I am calling fizzbuzz with 4 as a parameter and passing the result of that as a parameter to puts. Yes, it would still work with parentheses, as would that. We don't have double, triple equals anymore. That's not even, no one cares. So double equals all the way. Because it knows that JavaScript developers are around. Let's also do, make sure this actually works. In all of our cases, right? So at the end here we should have, yeah, cool. So that works just fine. And then it also does an interesting thing where technically speaking, we don't need the return keyword here. Because it basically goes as far as it can. And so rather than doing the if, like, you know how we would have like an else return, and you wouldn't have to have that else anymore. What we're going to do is we're going to structure it to be a little more declarative. So we're going to say if num is 5, fizzbuzz, else, fizz. And then here we're going to say else if, else. So have you ever heard Don be like, technically JavaScript doesn't have an else if? Well, yeah, this is what he's talking about JavaScript not having. This is else if. Right? So if num mod 3 is 0 and blah, 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 fizz buzz, else fizz. Else if num mod 5 is 0. And again, I can take out. And what basically is going to happen is that it's going to get to the end. It's going to get to the last segment it can get to, and if that's an expression, it's going to return that. That's its default behavior. in JavaScript, there is a default behavior. There's an implicit return undefined. Or if you ever use return semicolon, that is a return undefined, right? So this is just this is just Ruby being Ruby. Its default thing is you'll just return the last thing. Similar to how the arrow function works if you don't have curly braces. Who's used that arrow function without that curly brace? Huh? Anybody? You should. It's fantastic. All right. And if we visualize execution here, we have that same output. It's going to kind of assume that, whereas JavaScript sort of assumes you're writing functions as like procedures, you know, subroutines, as you may hear the term from time to time. Ruby assumes that you're writing procedures, you're writing functions that return expressions. That you're writing a function to get the expression. So you have to explicitly say return to return nothing. If I said here, return, that's what would happen. So. Now, its syntax, the way that its syntax looks is different than JavaScript's. JavaScript follows a syntactic style copied from C, right? That finds its way into C++, C#, Java, right? JavaScript looks like Java in the virtue that they both look like C. Whereas Ruby looks a lot more, it's in a class of languages that look a lot more like Python. So anyway, they're having a coffee break. I think now that you've seen it, this is a good time to have a coffee break, and then we'll come back and start getting into how the language actually looks. So. Yeah. Yeah. After the last end, yeah. Oh, I'm going to go break. Okay. I respect your life choices. Okay. All right, so that is some Ruby. So we have the def, if, and, else, if. We could also do, Ruby has a switch statement. I think it's called case statement. Yeah, and then they use, so instead of saying switch case, then it's case when. It is different. It is different. They do slightly different things behind the scenes. That's not going to be a problem most of the time. But okay, so here's some Ruby. We're going to talk about. I'm going to put strings and symbols above arrays and hashes. That'll actually be. Okay. Strings. Okay, let's actually get some Ruby running. I can say Ruby, and there's also IR. Okay, thank you. There's IRB, which is a the integrated Ruby something. I think it's just integrated Ruby. Usually when you see RB, it's like the RB stands for Ruby. Okay, so I can run stuff in here if I want to, but I don't. And Control-C doesn't work. It's like quit. Yeah. Cool. So strings. Strings. So there's two in JavaScript. Using the single quotes and the double quotes are basically equivalent, right? If you're using single quotes, you had to escape the single quote. If you were using double quotes, you had to escape the double quote. But that was the only difference between them. With Ruby, there actually is a difference between the behavior of the single quote and the double quote. So let's go single quote. Oh, by the way, I don't have to say var. Not sure if I left that out. I can just be like this, and it's going to be like, is that a thing? Well, I guess it's a thing now. So you have that to look forward to. So single quote, hello, double quote, hello. So let's puts the single quote and puts the double quote. Okay. Let's put, does single quote equal double quote? Yeah, they do. So what's the difference between them? That is the case. You have to use double quotes for interpolation. So let's do the interpolation first. So so let's just say there's some name. And then we can say a greeting is hi name. So hashing. And then let's actually puts. So we have string interpolation. That only works with the, sorry, not this. This won't do that. If we did, what will this, does anyone know what this will? Also, let's put a new line real quick. Does anyone guess what we're going to see? Yeah, it's going to be the literal string hi, right? So, yeah. So here's another thing. Escaping in strings. So in hi, Alethea. Let's do that again. You might already be able to see a bit of a difference. So what's going to be the difference here? Well, the difference right now is that nothing's going to happen because I didn't put puts. All right. But other than that, that sounds correct. Let's find out what happens. Yeah, so in this one, the single quote, the only escape it can do is a single quote. I can't escape any other character. So that is a limitation of the system. So that if your strings aren't working the way that you thought they should, you know why. So that's string literals. I feel like I knew an answer to that, so I'm going to Google that. Why did I Google? I was stupid. All right, backticks. Ruby. So yeah, there's other ways to kind of do these literals where you can kind of split them up, but also leave that alone for a moment. Jeepers. All right, symbols. Symbols. So, yeah. This is, I'll get to that in a second. Okay. So, JavaScript, well, I guess, let me put it this way. In JavaScript, when you guys were doing React, you had that whole, like, you had these messages coming in, right? And there's messages and notifications, right? In your React apps, in your chatty apps. Not just like in all React, but just like in your chatty apps. So you had, what were your incoming types? What were the possibilities? So incoming message and incoming notification, right? And then you had post message and post notification going out. So the server would take a post message, make an incoming message. Then you'd have a post notification, incoming notification. And, yeah. And then, like, there would be the type, and then there'd be the content. And the type was a string and the content was a string, right? Was the content meant to be seen by people? Like, that would actually show up on a screen that I would see. Yeah? The content, you know? But was the type ever actually seen by a person? But it was seen by the program, right? So you could say that with our strings, there's often ones that are never actually seen by a person, that are only meant to be seen by a program. In fact, you could have like a big thing of like incoming message equals 0, incoming notification equals 1, something something is 2, something something. Like you could make a gigantic list of all of those strings and assign them all to numbers in like one big const file, link them all up, and technically speaking, they'd all work exactly the same, right? As long as all parts of your program were like cool about what these numbers represented, you could have just replaced them with numbers, with like it's a list of integers, and we would have all been fine. We'd have all been cool. We would have all been a bunch of little Fonzies. Yeah? Who actually remembers Fonzie? Oh. Gross. All right. Who's at least seen Pulp Fiction? And when he says, we're all going to be a bunch of little Fonzies, and what's Fonzie like? And Yolanda says, cool. Yeah. Okay. So in Ruby, we have a way to denote, hey, this string, it's actually just meant for the program, not for the people. So for instance, if I were making a card type, I might be able to say rank is ace and suit. Not how you spell suit. Suit is spades, right? But these strings might not be seen by everybody, and I could type it this way and type it wrong in some other way. So the way we're actually going to do this is going to be, we're going to use a symbol. And a symbol would be rank is, colon, ace, and suit is, colon, spades. Now we can put ace here. Right, and it will put it to a string. But the idea here is that this is assigned to our program, to the rest of our programmer friends, that, hey, this is actually a client-only thing. If we use it later, we can see that, like, this will be true. There's also a really interesting thing about this. So let's do string 1 is incoming message. String 2 is incoming message. Okay? And I'm going to put string 1 equals string 2, right? Now, do we expect this to be, like, should this be a true at the end here? Well, it would be if I'd saved it. Yeah, it's true. Taking that's true. But there's also this thing where any item that was created gets an ID. See, like there's some number of where it sort of is on the heap of memory. And what you'll notice is that here's string 1 ID, and here's string 2 ID. What does somebody notice about these numbers? They're different. So let's do that same thing. Symbol 1 equals incoming message. Symbol 2 equals incoming message. Now, indeed, let me do a good catch, Sylvia. That was a test, and you passed. It wasn't. I'm just dumb. Okay. All right. All right, but now let's take a look at this ID. Let's take a look at just one. And what do you notice is different? It's a lot shorter. And then also, I feel like I'm setting up a long joke to which you probably already know the punchline. It's the exact same. So instead of creating a new string in memory, it found this. Instead of creating a new symbol in memory, it actually just found this symbol. I was able to compare it. So it's actually a faster use for performance reasons. And when you have a lot of things you're going through, this is actually kind of a good way to keep track of that. So that is a bit about symbols. And I think one of the biggest things you get from it is that for programmers, it's clear, oh, this is a programmatic string. This is a string to help me do things in my program. Yeah. You could do that. It's entirely possible. I feel like a lot of the Ruby that I've seen has been in the Rails has been in the Rails world where they haven't had to like compare objects to each other because they just don't care. It's been mostly about like, oh, I'm getting this from a database of fresh, and so yeah, sort of, but I'm sure you could, but also no. Also maybe. Yes, and then we'll see if this still works. Fine, we'll do it your way. The copy hadn't kicked in yet. Sylvia. I don't know, I'm a fraud. Okay. Puts symbol 1. Incoming message. So it stringifies it like that. Okay. Yes. So arrays work. Let's touch arrays.rb. Actually, I kind of want to. I'm going to skip arrays for the moment. I'm going to go to hashes. So. Okay. Yeah, hashes. So with hashes, we can create. The hashes are what Ruby calls, what in JavaScript we just call objects, key value pairs, these associative arrays, right? And one of the things about them is like, okay, so I'm going to make something real simple. Simple hash is name Joel hobbies coding mandolin annoying his wife. All right. Seriously, that woman. She's been through some things. So I'm also going to use puts with a simple hash, and I'm also going to use p, which is short for kind of like a pretty print of it. And you're going to get to see the differences between those. Sometimes you also see it written as pp in different ones. I know. I get what it sounds like. I know. So, and you'll see kind of how this is sort of built out. I guess these don't really do much different on this particular case. Sometimes they will, but that's not the point. So put simple hash creates that, right? And you'll notice it's a really interesting system here. So this is short. This particular syntax adopted from JavaScript is short for I have a symbol key that points to that. So these are now equivalent. A previous version would have been to use a string for that, right? So city of birth. Okay, I can't do all the lectures in Spanish, but like at least a little part of them when I can. Is going to be Vancouver. Now, you might expect these to kind of all be the same, like I would be able to use. So let's take a look at what comes out. So you'll notice that like this is symbol, string. Ciudad de Nacimiento is city of birth, by the way, just in case anyone was unclear on that. And if you were unclear on that, take interest in the world. Lots of people speak Spanish. All right. So, okay, now let's say I want to get something out. How would I do this in JavaScript if I wanted the name out of this hash? .name, right? Seems simple enough. But it says undefined method name. Whenever I have an object of any kind, and everything is an object, when I have one of these and I say dot something, that is always a method call on this. Every single time. This is where the object-oriented part comes in. It is always a method call. Every time. So for me to get this, what I really have to say is put simple hash, and I have to use the symbol name. Okay, well, okay, fine. It's a different syntax, but you're... All right, there's Joel. And I guess to get hobbies... Hobbies, I do that. And puts, by the way, kind of puts everything on a different line. I think if I used P, it would be... Yeah, it would make it into an array like that. So there's an example where P and puts actually behave a little bit differently. All right, so, and then I guess Ciudad de Nacimiento. It was too lispy. I heard myself, yeah. Right? And that. What? Nil? For starters, everybody, nil. Not null, nil. Why is that nil? Why is this one, when I use that symbol, why does it not actually return Vancouver? Because it was, and this will surprise you, a string. All right. That's right. So what I need to do here is if it was a string key, I need to use a string to access it. That will not do that. I need to use the string Ciudad de Nacimiento. Let's try going the other way. What happens if I try a string for one that is a symbol? What is your instinct about what should happen here? All right. And nil is what it is. So. Okay. Oh, well, that's coding. You'll also notice that the P works a bit differently with strings than it does than puts does. P puts the quotes around it. So, again, I'm not going to tell you all the differences between how puts and P behaves. Just point out, hey, they behave differently. Figure out what they are. So. Yeah, there's a thing about double colons, but that's for name spacing. That's a different matter entirely. Okay. 32. So that's about hashes. Also, very interesting thing happens with hashes when you actually call them in methods. All right, so let's take, let's say for instance I'm going to be def read out employee, and I want to have what their role is, and then the employee info, right? Okay, so let's p role, p employee info, and I'm going to say I'm going to say read out employee, instructor name Joel. All right, I don't need the parentheses, but I'm going to keep them. And also, I'm going to save my file. Also, I think I'm going to do a puts n in here, or puts new line. Instructor, name is Joel. Okay, I can actually, the same way that I can take off the parentheses here, I can actually take off the curly braces when I'm calling it as a argument to a function. All right, so instructor name Joel. Now, how many parameters have I passed to this function? 2, right? There's 1 comma, should follow. Languages, English, Latin, Koine Greek. I know, it's a stupid array of languages I have. Like, I guess some Spanish. That is generous. Un poco de Spanish. Right? How many, let's kind of zoom out on that. How many items am I now passing? I have a vote for 2. I have a vote for 3. And I'm going to say 5 because there's like a bunch of stuff in there. I have passed 2. What happens is that when it's kind of reconstituting this, it puts 1 there, it puts 1 there, and then, sorry, like that. So, and that's how it reads out. Yes. Yes, with curly braces. Question was, if you have 2 objects in the parameters, how do you specify the end of one? And the answer is with curly braces. All right. Blocks. Oh, blocks. All right. So, array.map. What does the .map function accept as a parameter? No, the array is this. It's on the prototype, right? So if you were creating the map function from scratch, you would be like this at right? So I ask a second time. Takes in a callback, a function. A function passed to a higher order function is in fact a callback. Yep. All right. No, it's fine. It's I that have failed you. So, right? So, how do we do callbacks in Ruby? We're going to use a mechanism called blocks. This is usually how we're going to be doing this. So, how do blocks work? They are weird. So, within our function, it's just a weird syntax. There are proper, what we call lambdas that we can pass, but here's what's going to happen. I'm going to make a function. Do something. Everybody, I'm still doing the yakety yak. So, so what I'm going to do is I'm just going to write the word yield. Now, if I Ruby blocks RB, it's going to say, hey, no block given, yield. Okay, so I'm going to pass a block. But I'm not going to pass it like, this is still my parameters list, but I'm going to write a block after it. And there's a couple of ways I can write this. One is that I can pass a code block like this. I have no parameters. If I had, and we'll get to parameters in a second, but I can say puts hi. In fact, I could say do something twice. And I could put, like, and what do you think this will do? Hi, hi. Right? So that's how I could define that. Now this is one of the two ways that we could define a block. The second is I could say do something twice, do, and then end. So I can have this is America. Don't catch you. Is it slipping up or tripping up? Slipping up. Yeah. So then it does it twice. I guess he doesn't say that twice. What he says is, this is America. Don't catch you slipping up. Don't catch you slipping up. Right. So let's try it again. This is America. Don't catch you slipping up. Don't catch you slipping up. Check what I'm whipping up. Right? I know. Very silly. Okay. So what else? We can actually pass parameters to blocks. We can call this with a parameter. So let's say that I'm going to say def greet name is going to be puts yield name. So this is going to expect me to pass a greeting style to it. And I'm using all my parentheses just to be very clear, but I don't have to use them all, but yeah, okay. So here I can say greet Frank, and I can define kind of parameter in here, name. And I'm going to return an expression here, right? What up? Name. Right? Another way I could restate this exact same thing is do name. Again, it's going to return my last expression. Yeah. It's just our argument list. Yeah, let's call them that. And if there is no arguments, we can just leave it out. Greet Frank, do name. Who's the man? It's insert your name here. I got it really impersonal when I said it like that. But let's do that. Okay. So yeah, there's an example of a couple examples of blocks. So what's an example of something we'd actually want to do with a block? Well, what's one of the things that we use callbacks for the most in JavaScript? Yes, asynchrony. That's true. Asynchrony. That's the word. Yeah. But what's the other thing that we use callbacks for kind of a lot? What did you use callbacks for in the first week, for instance? Arrays. Somebody give that man a raise. All right. So we have I think I just killed Dawn. All right. uh, the array, which extends the enumerable in Ruby. So we're going to look at that, and then we're going to look at arrays. Yeah, they have a bunch of things like find, right? And we can pass a block. That's going to have something nothing. So, for instance, and we have find all or select. So I can say here, if I wanted the odds is 0, 1, 2, 3, 4, 5. So how about this? All the odds to 100 equals. Now I'm always hazy on this syntax, so if I screw it up, be patient with me. Yeah, that's about right. So odds 1 to 100. Okay, good. No. Is it just? Yeah, that's what it is. It's like that. Oh, right. Whatever. We'll get to it in a second. I can say dot. So it's that p to 100 dot select, and my select doesn't take any parameters, but I am going to define a block. So I'm going to say, given a num mod 2 is not 0. And I'm going to do the spacing just to do the spacing. But now we should have 1, 3, 5, 7. Right. Right? So yeah. That is how we would do a block. Another block we could do is we could say, you'll have to see stacks like this. And then we might say each. And again, we would have that obvious, like now we can say just, okay, we know that that's the same as calling this. So I'm going to say each do num puts num. Right? So that's an each block. We don't need that. We can't include it. That's optional. I'm going to introduce one more thing. This is just a convention. So there is a convention that we can use the exclamation mark and the question mark in our methods. And the convention in Ruby is with the question mark that you would do it if the thing returns a Boolean. So if you have that, it returns a Boolean. And the other thing is that now I have to I can say, hold on. We put odd to 100 dot, and you have to say it like any? You don't have to, but I'd really appreciate it if you did. I want to be overhearing conversations where you're like, I think this would be a good place to use all? So are there any numbers greater than 100 in this list? False. Right? And then the other thing, and this is a thing, is we have odds dot to 100, which is now an array. We can, there's a few of these. I don't think any of them are here. I don't know. So let's look at array itself. Ruby array. Yeah, yeah. So there is a map function. Invokes a given block once for each element of self. So if we do A, B, C, D, it will map out, hey, A, B, C, D. But if instead of using the map method, we use the map method, what ends up happening is that it actually changes the underlying data in place. So sometimes you're going to see an exclamation mark, and what that means is there's two versions of this. One of them is kind of nice and gentle, and the other one's a little more aggressive. For whatever that may mean in the given context. In this case, the given context is that map is just going to give you a new array without changing anything, whereas map is actually going to change things in place. The same way that sort does in the JavaScript array. In fact, we have. Okay, here's the other thing, by the way. Ruby is sometimes too cute by half, and there's a bunch of methods on the Ruby array that are aliases for common things that we do with arrays and it dispirits me to even admit it, they rhyme. This is an alias for map called collect, and of course it's more extreme, collect! There is also select, which is a filter, and of course select. There is also reject and reject. Don't get ahead of me, man. All right. I think there's also inject. No. There's a bunch that rhyme. There's reject. There's a few more. Anyway, there's unique and unique. So that's a thing. Okay, so there's a bunch of stuff about reflection. I think I'm going to talk about it in the breakout. In the breakout, we're actually going to talk about classes and how to use classes. So right now, we've just been kind of talking about the extraneous of Ruby, and then we're going to talk about this in a bigger sense. Are there any questions? Calgary, you got any thoughts? All right. Okay, well, in that case, go away.